Section 8.2, solving inequalities using addition and subtraction, but this is for part 2, part A of your notes with the checkpoint. All right, so for the first part A of our notes, we're going to solve inequalities just using the addition property of equality. We'll do separate, and then we'll give you multi-step where you go between both of them. So solve x minus 6 is greater than or equal to negative 10. So this side of my inequality, the left side, is greater than or equal to negative 10. So I can see that the variable is being subtracted by 6. So I'm going to rewrite my problem, and I'm going to use my first inverse operation, which is addition, because we're using the addition property of inequality. So we're going to add 6 to both sides of this inequality, because we can keep it the same because of our addition property of equality. So then x minus 6 plus 6 causes those to be a plus 0, so it leaves me a single x, is greater than or equal to, and negative 10 plus 6, different signs, find the difference, and keep the larger number sign. So we get x is greater than or equal to negative 4. So to make this original inequality true, all the solutions for x to make the left greater than or equal to the right must be greater than or equal to negative 4. And then the original inequality will be true. It asks us to graph the solution. We can't just state a single solution because now in inequalities we have an infinite amount of solutions. So we have to show those infinite amount. We can't list them. We'd be here for days, months, years, decades, centuries if we were listing all those answers or solutions. So we're going to graph it on a number line. So again, we set up our number line. We must show the boundary point, and the boundary point is negative 4. So I'm going to put that in the center so I can show a region to the left and a region to the right so I can see what kind of numbers we're talking about in our solution set. So I'm just going to count up here, and I got to negative 1. I'm going to count down here. I got to negative 6. So I can see a region to both sides. I place my circle on my boundary point. Now I have to go back to my statement, my inequality statement, and see what kind of circle it is. Is negative 4 included as part of my solution set? And because of this equal to bar, negative 4 is a solution that will make the original inequality true. So that means I shade negative 4 in. It's part of my solution set. And then I need x is greater than. So where are the numbers that are greater than negative 4? Those live to the right. So I shade the whole region and line up the arrows, saying that all the numbers to the right, all those infinite numbers, are part of my solution set. So I have my simplified inequality, and I have my graph showing my solutions. That's what you're going to do for your checkpoint. So you have 3 here, and you have 3 little mini number lines that I set up for you that you're going to have to label and place the circles in shaded regions. So you're going to solve the inequality. So the solving process goes to the isolation of the variable. Then you're going to take that simplified inequality, and you're going to graph the solutions on the number line. It's b minus 2 is greater than negative 9. M minus 3 8/10 is less than or equal to 5. And 1/4 is greater than y minus 1/4. So again, take a second, simplify your inequality to a simplified inequality. Once you have the variable isolated, then you are going to set up your number line and graph the solution set. Now part B is using our second property, the subtraction property of inequality. So now we're going to solve this one-step inequality, and then we will graph the solution. Remember, this isn't a simplified inequality yet. We can't graph it just yet because the variable is not isolated. That's our first task. So I'm going to rewrite my problem. Negative 8 is greater than 1 4/10 plus x. So I have to isolate this. You look at the side of the variable to be able to isolate. We have 1 4/10 being added to x. So if I need the 1 4/10 to use an inverse operation, so I'm going to subtract the 1 4/10 from both sides of the inequality. So positive 1 4/10 minus 1 1/4 makes a 0, so I'm left with a single x on the right-hand side, and then I keep my less than, that the left side is greater than x, and then I simplify this side. Negative 8 minus a 1 4/10, same sign, so we find the sum, and we keep the sign. Because we're at negative 8, and we're going even smaller by 1 4/10. So we're at negative 9 4/10. So now that the variable is isolated, I can graph this type of inequality. Negative 9 4/10 is greater than x. So I'm going to set up my number line. I'm going to place my negative 9 4/10, and then I'm going to count. Because I'm in decimal world, I'm going to count by decimals. So this would be negative 9 3/10, negative 9 2/10, negative 9 1/10. So then this way, negative 9 5/10, or negative 9 1/2, negative 9 6/10, negative 9 7/10. So I have both sides of the boundary to show both regions. Now I'm going to place my circle on my boundary point. I'm going to go back to check. The sign does not have an equal to bar, therefore negative 9.4 is not in my solution set. So since negative 9.4 is not a solution, I do not shade that circle in. I'm not including it, but I'm including all the numbers that are less than negative 9.4. Negative 9.4 is greater than x. That means all my solutions are less than negative 9.4. So which side are the numbers less than negative 9.4? And that means that they're further away from 0 if they're less. So I am going to shade by arrow to the left, because those are the numbers, those are the solutions that are less than negative 9 4/10. Really, really important to be able to read this correctly. And I've said it in class yesterday and in notes last night, is that you really need to listen in your groups and to hear people say, is that less than or is that greater than, and start working with the symbols. So translating it into your hearing and to listen to know which way to shade and where are your solutions really matters in this case. So you're going to do 3 using the subtraction property of inequality. You're going to solve them first, isolate it down into that variable, and then you're going to graph the isolated inequality. So we have k plus 5 is less than or equal to negative 3. 5/6 is less than or equal to z plus 2/3. And our last one, p plus 7/10 is greater than negative 2 3/10. So take a second, isolate them, and then graph the solutions on the number lines. Proceed to part 3, which is the end of section 8.2.